just want to say hi to everyone around the country and welcome to today's LifeCourse seminar series. First, I'd like to take a moment to acknowledge the traditional owners and their custodianship of the lands on which we meet today. I pay our respects to our ancestors and their descendants who continue cultural and spiritual connections to country. And we recognize their valuable contributions to Australian and global society. I'd just like to introduce myself. If you haven't, this is your first LCC seminar. I'm Rennie Lee. I'm one of the co-coordinators for the LCC seminar series, and I'm located here at UQ. And Nancy Kong is our other co-coordinator from University of Sydney. This is actually our first seminar for the year. Both kind of COVID and some flooding has sort of delayed our start to the year, but we're really glad you're all here with us today. I wanted to introduce our seminar speaker for today, which is Dr. Martin O'Flaherty. He is a research fellow here at the LifeCourse Center at UQ and located at the Institute for Social Science Research. His research interests center on the intersection of family, health, and disadvantage over the life course. His work has contributed to the evaluation of nationally significant social policy, including the Try, Test, and Learn Fund. Martin's current research investigates the nature, causes, and solutions to poverty and financial insecurity among children with disabilities as well as their families. Today, Martin will be presenting some of his work on teenage motherhood. The title of his talk is, Does Anyone Suffer from Teenage Motherhood? Personalizing the Causes of Disadvantage with Modern Methods.
So just before I get on to the talk itself, I also wanted to acknowledge the traditional owners of the land and their custodianship of the lands on which we meet. So one of the things that I do is work on the LifeCourse Center Knowledge Transfer Committee. And I think for any researcher, probably the hardest form of knowledge translation has to be talking to your family about what you do for a job. So if I were to say to a layperson something like teenage motherhood, on average, decreases earnings by 10%, the first thing that they would probably come back to me with is a counterexample where somebody that they know is a teenage mother and actually they did really well, they made lots of money, they had a very high flying career. So that the unkind interpretation of that kind of lay knowledge is that it's subject to all kinds of cognitive biases, it's selective, it's generally pretty unreliable. But I think that's all true. But there's another sense in which, well, they may be right. And actually, there's no reason to think that almost anything that we care about, whether it's a life event, such as teenage motherhood, or a treatment or an intervention, there's no reason to suspect generally that those things should have constant effects across different groups and different individuals. None of us really believe that. So why should we care about this kind of heterogeneity in the effects of things? I think that there's very strong practical and theoretical reasons why we should care about it. So for policy, obviously, you want to deliver the right service to the right person. If we're not doing that, then at best we're wasting money. At worst, we're actually causing harm. When we think about knowledge translation, again, I think that lay people and not even lay people, but people who aren't researchers, often don't trust and don't see value in this kind of statistical knowledge about average effects. And realistically, why should they care? Because that's an average effect. It's not something that is specific to their particular circumstances. It's not necessarily really relevant to the decisions that they need to make. And then just theoretically, obviously, many of our theories touch on that effects should be heterogeneous in different ways and in different circumstances. And if we really try to deal with heterogeneous effects more systematically, then we can improve our understanding and our theory and go beyond what we've already got. So that's the first part for this talk. This is the second bit of my motivation. So I think probably most people are familiar with this replication crisis, where lots of high-profile studies, very influential, top journals, very exciting, and then you try to do them again and you don't get the same result. In fact, you tend to get much weaker results and might get entirely contradictory results. And that's a complex problem. That's multi-causal. But one of the things that's going on is this process of p-hacking, or selective reporting of results. People will select, you have a degree of flexibility in the way that you do your analysis and what you report, and that enables you to fiddle around with your findings to report something that is more exciting or more likely to be published. And that researcher-driven flexibility undermines the whole basis of our scientific endeavour. And I think it's important to stress, I'm talking about researcher-driven flexibility, and that's an important distinction that I'll come back to a little bit later. So when we think about the process that we go through when we're doing data analysis, we start out with theory and some questions and some data, and we want to arrive at a point where we've learnt something. But many of the problems that we have in terms of science and in terms of how can we make a difference practically with the knowledge that we generate sort of arise in this middle stage, like how do we do that? How do we translate theory and data into knowledge? And the core problem, and this is relevant for heterogeneous effects as well as the average effects that we're mostly reporting, the core problem is that we need a model to bridge that gap normally, but we don't know what model. So to do causal inference of any sort, you need some sort of assumptions, that's unavoidable. And with observational data where we don't have observation, we generally rely on something like this. So that's basically this assumption is essentially saying that, after we control for or adjust for or condition on the observed things that we've got, there's no residual confounding between the treatment and the outcome that we're studying. And that assumption is shared by lots of methods that you see across our literature. So regression, matching, inverse probability weighting, there's probably others as well. So if your data meet that assumption, then you can say that the causal effect that you're interested in is identified. So you can't verify that, it's an assumption, but it's true or not true for any given circumstance. But even if it is true, you still need to have a model to bridge the gap between your data and the thing that you're trying to estimate. So in general terms, we can think about that as a function f. So that's just the shape, like a linear model or static or dummy variables, something like that connects your treatment and your controls to the outcome. And depending on what you choose, that can affect the estimate of your causal effect quite a bit. Okay? So that's important. And this is where some of that researcher-driven flexibility becomes a problem. So if you ask people, well, how should we choose this? How should we choose this model that we need to translate data and theory into knowledge? Well, theory people will say it should be theory-driven. Well, I don't think theory is actually very much use for this particular task. It's not good for nothing. So theory is useful for many, many different things. So it's essential actually for us to organise knowledge, communicate, evaluate the plausibility of the assumptions that we make when we do causal inference and identify opportunities for causal inference. But there's really very little connection between the kind of theory that we have and a particular mathematical expression that we can use as a model. So it's not much good for that. So this is the statistical fiction about how we operate. It says that we know before before we do anything what the true model is. So we only have to estimate the parameters. We know what the model is. And we just get data, we fit one model, and then we just report our results. And everybody here knows that that's actually not what happens at all. We don't know what the true model is. And if we choose the wrong model, obviously, we're going to get the wrong estimate. And that affects heterogeneous effects as well, if it's not very obvious. So this is an example of a recent political science paper where the authors have gone back to a number of interactions that have been reported in the absolute top, most prestigious political science journals. And they find that actually most of those are not reliable. They're not robust, they're sort of model dependent, they're fragile to violations of linearity, violations of common support. So they can't really trust them. So we don't know the true model. That's the core problem. And that leads to lots of other problems. So we get things wrong at a basic level. We would like to arrive at the right answer when we're doing an analysis. The fact that we don't know the true model gives us this flexibility in how we do our analysis. And we pair that with publication bias and career incentives and all sorts of other bits and pieces that contributes to a distorted evidence base. And we miss heterogeneity. We don't pick up on heterogeneity because we don't have strong theory that tells us where to look. We tend to fit models that are simpler, that just assume that the effects are homogeneous, and we don't. What can we do? So this is the theory. This is what statistical theory says. It's one model that we've decided on in advance. We know what that model should be before we look at our data at all. And that's great, and it avoids this kind of researcher-driven flexibility, but we don't know what the model is, so the one model that we've chosen is probably wrong. So if we choose something that's too simple, which I think is probably what most of us do, then we risk bias in our analysis, because even if our data support causal identification, we haven't used that data sufficiently well to get a good estimate of the causal effect. And at the other end of the spectrum, if we could fit an extremely flexible model with high degree polynomials, lots of interactions, very many terms, and that will fit the data that we have in hand very, very closely. It will fit it really well, but it won't generalize. And our results will be subject to a really high degree of statistical uncertainty, right? So that creates just other problems. Here's a model based on the data through a formal process or just by eyeballing the results. But there's really, first of all, there's no reason to think that we've considered a model that's correct or good enough to get the correct estimate. We generally only look at a few relatively simple models, right? Actually, people might not realise, but when we do this process where we get one data set and we use that data to both select a model and conduct a final analysis, well, the standard errors for our final analysis are actually not valid anymore, because that process of selecting a model using data introduces an additional element of variability to estimate that's not accounted for. So what's our solution? How are we going to address this problem? We want something that will be low bias, so accurate in estimating the effects that we're interested in, efficient, so we don't want something that is going to be subject to a lot of statistical variability or very uncertain estimates. And we want something that will let us pick up heterogeneous effects. And all of this we want without knowing what the true model is in advance. So for us, we've chosen to use something called BART, and that's Bayesian additive regression trees, which is, it originates as a model with Shipman and his colleagues, and was originally suggested as a tool for cause and inference by Jennifer Hill 10 years ago now. And at a high level, I guess BART itself is a very flexible model. So BART, I'll come back to that in a minute. So this is one of the big advantages of it, is that the model itself is quite flexible in the way that it fits to the data. But that actually means that we, as researchers, we don't have to be flexible, okay? Because we can, with a reasonably high degree of confidence, we can fit this model to the data and expect that it will give us a reasonably good fit. So the base element of BART are these things, regression trees or decision trees, which you may not be familiar with. So essentially, decision trees partition the data sequentially. So it like splits the data into different groups, and in each group you have a different estimate of what the outcome should be, or the average of the outcome should be. So single trees have some nice properties because they can split on different covariants. So you might split first by sex and then by age in a tree. And that gives you effectively an interaction. That gives you an interaction of sex by age, which, that's important because interactions are what give us heterogeneity in effects. They also fit to nonlinearities, and they're not affected by outlying values in your covariance. Okay? But as you can see on the right, with the blue line, single trees have some severe limitations as well. So they produce this lumpy fit to the data. It sort of follows the true response curve, which is in black, but it's not very close to it in lots of places. Right? So for BART, what we're doing instead is we're taking hundreds of trees, hundreds of little trees that are all sort of constrained to be quite small and explain only a small part of the data, and we add them together. And in doing that, we essentially inherit all of those benefits of single trees, but we get a much smoother fit to the data. So we fit the data much better, but without going into the technicalities of how this happens, BART also manages this balance between under and overfitting the data. Okay, so it produces an appropriately complex fit to the data. So why do we use BART? So we don't need to know what the true model is in advance. BART will approximate the true function pretty well, even though we don't know what it is. It will detect heterogeneous effects automatically without us needing to know where we should look or what those effects should look like in terms of the functional form. It deals well with lots of covariates. So for traditional methods like regression or matching, they start to break down once we add more covariates into the model. And BART still handles that scenario pretty well. And that's valuable in that it might, depending on what is in your data, help to support the plausibility of the assumptions that you need to make to draw causal inferences. And just to come back to this point, we can fit just one model. We can just fit BART once and report the results. We don't need to go back and forth to select between different models where we run the risk of, consciously or unconsciously being influenced to choose a result that suits our hypothesis. And beyond sort of those are kind of attractive properties, but BART also just performs well in practice in estimating causal effects. So these graphs are taken from a data analysis competition with simulated data. So the true effect is known, and we can compare the performance of different methods. And we see actually that on the left, we see that BART is as good as the best of the researcher-driven methods in estimating these effects. So part of the competition, we had actual teams of researchers go and analyse the data, come up with their best estimate, and BART is just as good without any researcher input. And secondly, if you compare across a much wider range of different data sets and different data generating processes, BART on the right, you see, again, outperforms all of the other black box methods that don't need researcher input. It's also relatively efficient in that the credible interval is quite narrow. It provides good estimates of subject-specific, like individual-specific causal effects, and sample average causal effects that we're typically interested in. So let's see this in practice. So this is an example that I'm taking from. So this is an example from a working paper of mine. Teenage motherhood, probably has a bad reputation, whether that's warranted or not. There is some evidence that it might affect the mother's long-run mental health. Okay? So that might happen because of us, because we discriminate against and stigmatise teen mothers in many circumstances. It might happen because of a process of cumulative disadvantage. So motherhood, adolescence occurs at a time when they're not personally or financially or socially ready to become parents, and that can disrupt education and skill formation and have lots of different processes that might ultimately affect mental health. And lastly, there's increasing awareness that adolescence is a sensitive period for mental health. So after infancy and the neonatal period, adolescence is the life stage when our brains are developing fastest. And in particular, the prefrontal cortex develops quite a lot during adolescence. And that means that we're vulnerable to stress and isolation and some things that might not be so consequential at other times of our life can have bigger effects on our mental health in adolescence. Pair that with stigma and disadvantage and all the regular stresses of parenthood, you can see why there might be a particular effect of motherhood on mental health when it occurs for adolescents. So that's the story. The evidence is not so great. So the evidence is pretty patchy, actually. There's a number of different UK studies that have found consistent evidence of detrimental effects of teenage motherhood on later life mental health. They're all sort of observational studies with not many controls. So quality, I would say, but that's the evidence. Probably the most persuasive evidence comes from these two twin or sibling studies, one in the US and one in Norway, that find effects of teenage motherhood on mental health. But there's a bunch of counter examples as well across different contexts. So it's really far from clear whether there is or isn't an effect or where there might be an effect. There's also this counter-narrative where the teenage motherhood is sometimes seen as a turning point or a transformational positive event for some adolescents. So there's lots of qualitative examples where mothers will say, oh, it gave me a new sense of purpose and meaning and social connection, and I had to get my act together and get a job and finish school. And there's even a little bit of quantitative evidence to support this as well. See on the right, this is taken from a recent paper in JMF, where they show that, or what they report to show is that adolescents who thought that teen motherhood would be okay and then actually become teen mothers have better mental health in the long run than adolescents who thought it would be okay but don't become teenage mothers. And so there's a little bit specific about like who might be affected. So there's some evidence of heterogeneity and effects on mental health specifically. And there's also evidence that the mechanisms that I've talked about might operate differently across contexts as well. See on the right, this is taken from a paper that shows the effects of teenage pregnancy on high school completion in the US as a function of the probability of teenage pregnancy. And what they're showing actually is that the effects of teenage pregnancy are really most acute for adolescents who are pretty much never going to become. So these are our questions. Does teenage motherhood affect long-run mental health on average? For our sample, on average, is there an effect on mental health of teenage motherhood? And second, for whom is teen motherhood consequential for mental health? And if I hark back to some of the stuff that I've talked about around heterogeneity, this second question is really very general. And that's because we have sort of a strong sense that the effects might be heterogeneous, but we really don't have strong theory that would point us in the direction of what specifically should drive heterogeneity in teenage motherhood. If you're interested in reading a longer version of this, you can find it in the working paper series. Data comes from the British cohort study. You've got outcomes from 30 through to 42. I think one of the notable things here is the covariates that we're controlling for. So we've got 70 of them, measured from birth to age 16, covers 13 different topic domains. And that's quite a rich set of covariates. And that's an example of something where it supports the plausibility of this core assumption. So it's still quite a difficult assumption to believe. So don't get me wrong, it's still a challenging assumption, but it's more plausible because we can control for this very rich set of background characteristics. And that's something where I think other methods would struggle to include such a rich set of potential confounders. So this is the workflow that we're going through. So we prepare the data, we estimate the probability of teenage motherhood, and we include that as a covariate. And then we fit our model. So that produces this black box function, which we can't interpret in itself, but we do use that function to compute what the average treatment effect and the conditional average treatment effects are. So the conditional average treatment effects are subject specific. But the average effects, okay? And they're just specific to a very narrow subgroup. So just descriptively, we see that before we do anything, there's reasonably large differences in mental health between teenage mothers and women who became mothers at an older age. So there is a substantial difference there. But that doesn't really stand up to controlling for all of these different things. So there is one instance at age 30 where we see that there's about a 3.5 percentage point increase in the risk of poor mental health. That's very close. The lower range of that credible interval is very close to zero. So, there's still some residual confounding out there, if we're honest. And it wouldn't take much to make this something where we could reasonably believe that it might still be zero. So I wouldn't hang my hat on this result. We did a little bit of sensitivity analysis around different definitions and different counterfactuals. Up the top, the different version of what counts as a young mother doesn't really seem to matter. Down the bottom, we see that the counterfactual does matter a little bit. So compared to women who had their first birth in the early 20s, there's really nothing going on. But if you compare to women later half of their 20s, that's a much larger effect, about 5 percentage points. Heterogeneous. Let's have a look at the Kates. So this, on the left, we have the subject-specific the sample distribution of the subject-specific Kates. So there's one estimate for every person in the sample, and really they just don't vary very much substantially. They don't vary substantively in a way that's meaningful. And we see that on the right as well. That's the plot of all of the effects. It's the black line in the middle, and then the uncertainty around them. And you see that the uncertainty is just much, much bigger. That's really a similar story for the other outcomes as well. So if we zoom out, well, what did we find? Well, we don't really find strong or consistent effects of teenage motherhood on mental health. And that is different from what previous UK studies have found. So departing from the existing literature there. The only place we really find a meaningful effect is comparing to women who gave birth in the latter half of their 20s. But I'm not really sure that that's a realistic counterfactual, in the sense that I don't think that we have interventions available to us that could really delay birth by that much. So I'm not really sure that that's a useful finding. And we found that the effects are largely homogeneous. And that seems boring, since we always assume that our effects are homogeneous implicitly, or mostly we assume that they are. But it's actually practically important that we've been able to show that. sort of suggests that, well, there's no subgroups here where we could find somebody who we should be seeking to prevent teenage pregnancy in these groups, or we should provide additional support to teenage mothers in these groups. What's the need for that? So let's come back to the method. So what can BART do for you? BART has low bias in estimating causal effects. It's efficient in estimating causal effects, and that can help us to be right more often. Something really basic, that even if we're totally uninterested in heterogeneity of effects, we should want to be right more often. And I think BART can help us with that, at least in some circumstances. We could pre-register our analysis, and that's something that gets around this whole researcher-driven flexibility. If we can say that, well, we're going to use BART with these covariates and this outcome, and that's something we can credibly say in advance without needing to play around with our data to get a model that fits well. So for this paper that I've just talked to you about, we didn't pre-register just because this was the first time that we had used BART. So we felt that we needed to get our hands dirty a little bit with the model before we say what we're going to do. But for upcoming analyses, we are getting ready to pre-register our analysis of observational data. So that's something that I think could be quite valuable. And we can focus on what we do at, which I'll come back to in a sec. So it can free you from doing this kind of model fitting process to do things that your expertise actually really supports, and it can give us heterogeneous effects. So just coming back to what I mean by focusing on what we're good at. Because BART is this black box model, there's potentially a sense that we're advocating theoryless, data-driven research, and that's actually not at all what I'm suggesting. What I'm suggesting is that theory just isn't much good for this one particular task of specifying a model. And it would be better if we could have a way of doing that effectively, but actually spend most of our time and our energy and our efforts on other things that matter just as much or more to the quality of our findings and our results. So, I think that I'm sure that people will have some reservations about all of this, and I wanted to anticipate and respond to those quickly. So, in many circumstances, we're probably not going to be interested in heterogeneity at the individual level. That's perfectly reasonable. So theory has to operate at some level of generality higher than individuals to be interpretable and usable and scalable. So we can still do that. If you have a particular hypothesis about moderation by a given covariate, that's fine. We can do that. Report that over heterogeneous effects over values of that covariate. An example of that is here on the right. So these are just interactions, but they're interactions where we didn't have to specify in advance the form. That's helpful because we don't really have theory that would suggest a lot of this to us often. I think if we're operating more of a discovery-oriented frame of mind, might also do some post-estimation analysis. So we take all of the individual level effects, what the Kates, and then we get what factors discriminate between people who have higher or lower effects of treatment. One way that you could do that in a number of ways, but one way that people do that in the literature at present is by fitting one single tree at the end, one single regression tree at the end, to distinguish between people who have high and low treatment effects, and that gives you something that's interpretable. So you get different larger groups where you can interpret about why they might have bigger or larger effects. But it's a black box, so that sort of, I think in some quarters at least, would create some suspicion or uninterpret it, so what's useful. I think my response to that is, well, that's hardly any different than what we do already. So my favourite example of this is odds ratios, which everybody here today has used and interpreted an odds ratio. But I think often we really don't understand what they are. Searched for probably 15 years, and my brain still does not think easily in odds ratios. So generally I would say to people, well, you should translate this into a marginal effect in percentage points, because everybody needs to do percentage points. And we can do the same thing with BART. So we can get something that we can understand easily at the end from BART straightforwardly. And that's what we're doing here. And we don't need to understand all of the rest of the model. We don't need to understand all of the things that are happening that without just want to understand the causal effect. So, just to be upfront, obviously I'm selling BART, but in many cases probably you will get the same effect. So the model that you fit is really only one piece of the puzzle, and data, and the data is probably more important, really, like what the data is actually like. But we can't know in advance when we're going to get results that differ. And in that sense, I think that it's important that we think about how can we choose something that will work in a lot. Okay? And offers that. So I've been talking about observational data, but BART is just as applicable to experiments. So an experiment kind of gets around the problem of identifying the average effect, but it still doesn't provide you with a good way of understanding heterogeneous effects. You still need a model or group or pre-specified groups where you're going to look for heterogeneity. And that suffers from the same problems around, well, theory often just doesn't help us to know where we should look very much. So what's next? What's coming up? So first thing that I'd like to do is to have some capacity building in BART so that you as potential end users can access this and apply it in your own work. So we've already developed some software that translates the black box of BART into causal estimates. And you can see that on the right. That's been developed by my colleague Josh Bond. We'd like to develop a Stata interface for BART as well, since this presently is all in R, and that's probably a barrier for many people. I also have a number of projects coming up that they're substantive projects, they have their own life, but I do hope that they will demonstrate some of the power of BART. So both of these projects at the top here are with large-scale administrative data, and for both of them, we would like to pre-register some analyses. Before we get the data, we'd like to say what we're going to do, or before we fit the model, we'd like to say what we'll do. And because they're so large, they also offer us this opportunity to have a holdout data set where we can keep some data in reserve, and once we've done our original analysis to our satisfaction, we can replicate it on that holdout data. So that will hopefully provide us with an additional degree of reliability around what we do. I'd like to close by reflecting on the LifeCourse Center's mission and how this can fit in. So this is all language that I've taken from the LifeCourse Center funding application. So you can see all through here is this language around personalization, individual differences, and tailored customization and personal circumstances. So I think that this idea is something that we collectively believe in, and it's certainly something that I believe in as an idea, something that can be transformative in the way that we approach our work. But how do we make it work? So I think, as I alluded to at the start of the talk, I think that when we talk about heterogeneous effects and personalized effects, that really has to be tied to knowledge translation. Because why would we want to know what the effect is for, or an average effect is for a particular person, if we're not going to use it to make a decision for that person? or that person won't use it themselves. So there's different levels of aggregation where we need to communicate our results, from very high levels through to something that will be very particular to the person who's using it. And in a policy sense, I think that there's personalisation really means decentralised authority or decentralised decision making, where in lots of different domains we're pushing decisions down the tree. So bureaucrats are not making choices. There's many choices that are just made at the level of schools or families or neighbourhoods. If we're going to reach those people, if we're going to provide our knowledge to those people in a way that can be used meaningfully and effectively, we have to provide them knowledge that is relevant to their personal circumstances or their particular contextual circumstances. I think we also need to be aware of some pitfalls or potential pitfalls along the way here. So when we think about heterogeneous effects and all this kind of stats and stuff, that's part of the puzzle. But it's never going to work just by itself. This is a whole pipeline and a whole approach to delivering. We need people who are going to use the evidence to trust it. We need them to believe in us. Providing high quality evidence and being transparent about how it was produced. To respect the agency and the knowledge of people who will be making decisions in local contexts. We don't know everything about them. This is only one piece of knowledge that we hope we can provide. And we need to understand that knowledge translation is an intervention in and of itself. So when we do this, I think that there can be unintended consequences. We don't know whether it will work. Maybe we're providing the right information, but not in the right form. So we really need to follow up when we're doing knowledge translation. And we need to study what actually happens when we do this. So, heterogeneous effects are one piece of the puzzle. I don't think that we can meaningfully say that we've delivered personalised solutions unless we have reliable knowledge about what works for whom. But it needs much more. It needs engagement with stakeholders and communities and policymakers. It needs multidisciplinarity. It needs multiple methodologies, communication, qualitative work to understand why this works for some people and not for others. Lots of different pieces to make this work as a solution rather than just as a piece of research. So there's many different bits and pieces, and look, I do hope that Bart can feed into this and that can contribute. But really, what we need is partnerships.
Thank you, Martin. That was very thoughtful and thorough, and I thought actually really enjoyed how you're kind of using a methodological issue, but expanding it with the example of teenage motherhood. And I thought that was really well done. I think I could speak for myself and some others that we probably were all kind of reassessing the appropriateness or efficiency of some of the models that we've been using in our own analysis. So this is from Rihong. Could you elaborate what's the relationship between overfitting and a causal relationship? My limited understanding about overfitting cannot lead me to a causal relationship.
So underfitting or overfitting is about the robustness of the estimate that you get from the data. It's not about whether an effect can be identified with your data. That's something that you have to assume. You can't verify it from the data. Something that you have to support substantively based on what you understand about the field, about what things contribute to the treatment or event that you're interested in and might also contribute to the outcome. So you need to be able to sustain that assumption substantively. You can't verify it. But if you're willing to sustain that, and implicitly we generally are, because that's what we do whenever we fit a regression, we're at least implicitly in a causal way to get a good estimate, you need to have a balance between underfitting. So that idea of underfitting and overfitting normally comes from prediction, and that's what machine learning is good at, right? It's good at prediction, and that is where this idea comes from. But it turns out that balance is quite important to get robust causal estimates as well, because you can think about the process that we're going through essentially as out of sample prediction. So for each person, we're essentially predicting what would have happened to them if they didn't experience the event that they did experience, or the converse, right? So this is important for causal estimation as well, but that's separate from causal identification.
I guess I have a question, Martin, because I think I assume for most of the audience, this might be a new kind of method they're not aware of, or maybe not familiar with. How would you suggest people, if there's interest in getting started, how would you kind of even get your feet wet with this process?
People are welcome to come and talk to me if they're interested. I can also provide a bibliography around this. But I guess, so we've got the training hopefully coming up. So that's something that I have in development. I'm going to sort of have perhaps a one-day workshop, which will be just a hands-on thing. So how do you apply this in practice? What buttons do you have to push to make this happen? And I should say at this point as well, it's actually not really more complicated than running a logistic regression. So if you would like to, the hard bit is really around the assumptions, and that's something that you as a researcher need to think about substantively. But if you compare this to a logistic regression, none of us could go and sort of fit a logistic regression from scratch. None of us who use logistic regression understand all the nuts and bolts of how the parameters are estimated. And it's practically, this is, I think, actually more reliable, because you don't have to go through this researcher-driven, error-prone process of going back and refitting models that, first model doesn't fit the data well, and you have to go back and fiddle with it. So I think this is better, and it's just as accessible once you overcome the initial barriers to understanding what's going on.
Right, thank you. Martin, great presentation. Very easy to follow, very instructive. I just wanted to probably make a little comment because I am economist, and economists are obsessed with causality. So whenever there's a causality mentioned in a presentation, we start twitching, And the BART method is interesting in this regard, although I will push back a little bit on the notion of low bias in the causal estimation, because I think that this statement is only true if you observe all the variables that are relevant for the outcome that you are evaluating, right? Or in other words, that there are no omitted variables in your model, right? In reality, this is almost never the case. So we have to be very careful with calling things causal if there is a potential for omitted variable bias, because BART cannot account for these issues. So that's just something that I wanted to mention. And the other thing was that just kind of thinking about your sample, you have about 2,000 or 3,000 women in your sample and 400 teenage mothers. And given that BART is a method that is trying to balance the interactions, the amount of interactions with the model with the overfitting, it will be necessarily using a subset of the interactions or some small kind of dummied out notion of these interactions. Which means that even though you have 70 variables that you are theoretically controlling, practically you're controlling for much less. And that again kind of plays into the narrative of potential omitted variable bias. So basically, I just wanted to kind of point these out because these are notions which we should be also very much aware of when we are thinking about the designs and about the methods and about what can be supported by the data that we have at hand.
Thanks, Jan. Look, I totally agree with you. So I think that it's, practically in most circumstances, it's not about fitting the right model. It's about whether your data really supports causal inferences in the first place. And that's something that's not on the model. That's on you as a researcher to either, support that or not support that. And practically, I actually think that many of the studies we do we just shouldn't do in the first case because they don't, there's just no possible world in which we could reasonably substantiate this assumption that there's no residual confounding, right? So why are we doing this analysis? Why do we actually bother to run this and control for a million things and spend all our time to report something where we could never reasonably believe the assumptions that underlie it? Okay? And in this particular case, I think that it is still a risky proposition what I'm doing, okay? Because even though I've got lots of covariance, there's probably still some residual confounding. But if I compare what I've done to what is standard practice in many disciplines, sociology, epidemiology, many other disciplines, I think that this, like being able to include so many covariates, does make that assumption more plausible, probably reduces bias. So it's not necessarily that this is the correct estimate, but it is a more plausible estimate, I think, than what we would get in most circumstances where people would do this anyway. And they would just run a linear regression with a few controls, or they would do some kind of matching with a few things, and then they would report their results. Probably, this is something that frustrates me actually, is that people do this dance where they say, oh, these are not causal estimates, but then they jump right to the policy implications and how this should transform the world. And it actually, in an earlier version of this slide, of this presentation, I had to cut it back a bit, but I had a screenshot from one of Janine's papers, just picking on Janine, sorry, but where this happens, like within an inch, where they say this is not a causal estimate, and then we go straight to
Martin, how dare you pick on me?
Straight to this shows that our treatment affects this outcome and we should change policy as a result. So I think, I just think that we should be honest about what we're doing. I think that we should, if we are all interested in causality. Economists, to your credit, I think, much more explicit about what the real goal is. Sociologists try to dance around it. But I think we should just be explicit. And we have to acknowledge that there are flaws in the data analysis that we do. There's limitations in what I've done. That's not like a final analysis. So, sorry, I'm still going. So that's part of my response. In terms of your other question about, I've controlled for all these different things. So I've also controlled for the propensity score. And that practically turns out to be an important step when you're using BART, because it provides a low-dimensional summary of the confounding in the data. And that's helpful for fitting the data, because BART does have to shrink back. It has to regularize the fit so it's not too complicated. And that can reintroduce confounding in some instances. So the propensity score is sort of like a low-dimensional summary of that helps to improve the estimates in practice, because that can pick up, if it's estimated correctly, and then we've used BART to estimate it again in our case. If that's estimated correctly, then it can pick up all of the confounding that you can get from your controls anyway, right? So that's an important step in practice. And last thing I'll say in response, this is when I say that there's no heterogeneity, or we didn't find heterogeneity, that's data dependent. This is the amount of heterogeneity that we could find reliably with the data that we have. So with other data, better measures, more data, you would find a different result. Okay, so, and that's fine. But what these results suggest is that, at least with the data that we have, which is pretty rich and pretty high quality, we can't find anything meaningful that we could use. So we can't find reliable heterogeneity that we could use here. And we look. There are reasonable theoretical expectations for why there might be, but we couldn't find it. And I think that showing that is valuable.
Right.
Sorry, one.
Okay.
I know this is the long answer. Just because Jan's concerns kind of go to the core of what I'm interested in as well. So you can also, there's an instrumental variables version of BART. I haven't used it myself, but it exists. So if you like, I can point you to that. You can look it up. And as I've said, you can use this with experiments just as well as you can use it with observational data. Okay, so with an experiment, we don't really know. Obviously, people try to hypothesize what might drive heterogeneity or re-register what subgroups they're going to analyze over, and they do that, but that's ineffective. We don't have strong theory in most cases that actually tell us where there should be heterogeneous effects. We can't actually afford to just do 1 million experiments where we pre-register all of them and pre-plan all of our different subgroup comparisons. That won't push science and our ability to intervene and help people forward fast enough. So this is something that, it doesn't solve all of the problems around causal inference from observational data. I'm 100% not claiming that, but I think it's a valuable tool in lots of circumstances.
So I'm just conscious of the time that it's already 1:02, but there is an extra question from Richard Morris. So I would encourage if they could just maybe contact Martin directly, or Martin, if you want to reach out to them for the question, just given the time. So I just want to say thank you again to Martin and the audience. I just wanted for attending today. I also wanted to let you know that because we have monthly meetings, if any of you are interested in presenting in the LCC seminar or think there's someone that would be good to present, please send your recommendations to myself or Nancy Kong. We have another seminar planned for April 2nd, which is Mary Alice Doyle, who is at London School of Economics. I guess with that, I'll say thank you to everyone for attending, and feel free to email any of us, or me and Nancy, if you have any questions. And then if you have obviously questions to Martin, please direct them to him. Thank you again, Martin, and everyone for attending.